They hear me? Who's they? He doesn't talk unless it's...
So, our task here is going to be to rotate a figure and reflect a figure around a line. This figure has already been reflected once. So we started with this highlighted yellow figure. That was the pre-image originally. It got reflected. You see the line it got reflected around? This green one here, right? And then the resulting image was the blue one. Your job is going to be to take that blue figure and to reflect it across this red line. Marcus.
Can I see your finger when you point?
No. Ryan.
So we start by reflecting the yellow one across the red line and then...
Nope, you don't have to reflect the yellow one. Your task is to reflect the blue one across the red line.
You just do the same thing you did to reflect the yellow
Yep.
one.
So, your task with your compass and your straight edge is to do that along with the partner right now. Okay, so let's talk first about what do you observe. Raise your hand if you observe something meaningful. Rayanne.
Point R is like it rotated around point R.
What rotated around where?
The triangle.
The triangles. So, if I take, there are three triangles, so which two triangles are you referring to?
The gray and
The gray and the yellow one, did they rotate around point R?
and the white one.
And the white one, is it also rotated around point R?
Yeah.
Okay. So what do you know about this reflection that we just did? It's a reflection and it's also a rotation. Could I figure out the measure of the rotation that we just did? How would I do that?
Oh, I know.
Sarah?
Get 1 point on one triangle and the same point on the other triangle and then measure the degree.
Connect it to R and then measure the degree?
Yeah.
So where does this point correspond to in the yellow triangle?
The one on the red.
So if I can measure this angle here, let's try again.
Ooh, I did it.
There you go. 147 degrees. That is how much we rotated it around point R. Right? In this picture. I mean, I don't know how accurate that is compared to what's in your workbook.
Well, that
But-
one is like from the white triangle to the yellow triangle, but what about from the gray triangle?
Well, what do you think it'll be from white to gray?
Well, half of 147.
Where do I need to move it to? Over here, right?
Yeah. 77.
Is that about half of it? Yeah. Okay. Cool. So you can have situations where a reflection and a rotation are the same thing. And there, point R represented the rotation. The line represented the reflection, right? Because I reflect around a line, but I rotate around a point. So when you reflect a figure across a line, the original figure and its image share a line of symmetry. We've called that the line of reflection. But when you reflect across a line, then reflect the image across the line that intersects the first line, and your final image is a rotation of the original one. The center of rotation is the point at which the two lines intersect, and they say that the angle of rotation was actually 150 degrees. We proved them wrong. So what we're going to talk about now is that there are three different kinds of symmetry to figures. And you already know some of these. You're going to get a chance to come up and show me the kinds of symmetries that you can identify. Brett, stay awake. Take your hoodie off. That way you're less comfortable. Okay, line of symmetry of a figure. What kind of a triangle do I have here, Brendan? The top right. Isosceles triangle. Is there a line that I can draw so that the left side of the triangle will reflect across onto the right side? Rayanne, where would you draw that line?
Draw the line in the middle, so like find the line.
Come on up and do it.
Yes.
Well, how do you? No, no.
Let go when you want.
Wait, no, I don't want it right there.
It's not a perfect sentence. Right next to it. You have to come this one more.
Oh my god.
There you go. Now, where do you want it to go?
It's not very.
Try again.
Okay.
Perfect. What do you think this kind of symmetry is called? Line symmetry? What transformation would you use? Reflective symmetry. Okay, so this is a reflective symmetry. Reflective symmetrical line. What is this line also called? This line meets at what angle down here?
90 degrees.
Okay. So anyone know what that line is called when you drop something, a line that makes 90 perpendicular? It is perpendicular. When you drop, if you take a figure, anytime that you drop down a line that makes 90 degrees to the base, that is called an altitude. If you didn't know that.
So if it does it horizontally, it's called
No. We still call it an altitude. Just call it an altitude. Does every figure have a line of symmetry like that?
no.
Okay. So now let's go into, Marcus, here's your opportunity. Oh, you're going to pass? Okay. So your task is going to be to come up to the board here, and in each shape,
I'm gonna do it.
draw a line of symmetry that cuts it in
I'm
half.
gonna do it. Can I do it?
So let's start with the triangle. I'll give you a little time to think about it. Where can I draw a line of symmetry on the triangle so that it's a reflective
You can't.
symmetry? Sadie.
You can't.
I want to write Kimberly.
Is it all like?
It's ready to go.
Wait, you can do
Then
that?
it's like right here. Is that right?
So is that a line of symmetry that you added?
No, you can't do that. Stop.
Okay. Does anyone think you can do it?
You
No.
can't.
You can't.
Okay.
Right.
On this triangle, it is
The
not
angles
possible.
are different.
Because even if I, like the closest thing I could try to come up with would be something like this, right? But will that work?
Oh.
I don't think it will work because where is this point going to end up going? Remember, it meets 90 degrees on the line of reflection, right? So it's going to end up somewhere over here, and that doesn't reflect onto itself. Because remember, the definition of reflection is that it's going to go 90 degrees to the line of reflection,
It works
and then the
on-
distance is going to match, right?
It works on the bottom one and
Does
the
not
top
work
one, but it doesn't work
on the
top
triangle.
right one.
Okay. So who wants to try the?
Me.
Who wants to try the rectangle?
I do.
Okay, Sarah. Just draw one so that everybody gets a try.
Okay.
You don't want them to feel left out.
Oh.
Nope.
No.
Just go ahead and draw it.
Go.
Just draw over it. There you go.
That's
enough.
uneven.
Good enough though. Will that work?
I
If it
didn't
was
do
in the
it
correct
that
spot.
soft. Like tweaking out.
Let's just let you know that it's recording control.
Oh, it's recording.
It's recording right now. Oh.
That's why it's okay.
Stop.
All right. Who else wants to come up and draw another? Is there another one?
Yeah, the
Colton.
bottom left one. Bottom right one doesn't work.
Actually, just kidding, it does. You can do it like that, and then it'll go.
There we go.
That doesn't work. No?
Okay, will that one work? Yes?
No.
Thumbs up, down? No.
No.
It'll work, the other one's not there.
Everybody votes. So if it works, put your thumb up. If you don't think it works, put your thumb down.
Yeah. No, it doesn't. 'Cause they pull it up.
So if you have your thumb down, raise your hand if you think you can come up and prove it. Okay, Sarah?
Because we're going to fold this over like this, and it's going to be like that.
So rather than saying this and that, can you make a mark? Pick one vertex and move it. Reflect it across that line, see if it works.
You mean like draw it like that?
Yeah. Perpendicular to the other one, right?
Huh. Ah!
Hold it.
It would go like...
Perpendicular. So you're going to have to move it so these two lines are perpendicular. Keep going down. See, that's not 90 degrees.
There.
Okay.
That's not
Okay, good.
See?
So if you take that top left vertex, and it's going to get moved down here somewhere on the line that Sarah drew. You see how it doesn't reflect across itself when you go diagonal, Colton? Okay.
I was thinking the other one wasn't there.
Yeah, then it will work. But.
The bottom right
Okay.
one.
Is there another line of reflection?
Yes.
Dylan.
Thank you.
Quickly. Okay, waste some time.
I said horizontal. So that's what we're going
Okay.
Oh,
Let's
it
go.
is right there. Dude, I just wanted to see where it was.
Why did you go so far?
Okay, will that line of reflection as horizontal work?
Nope, it's crooked.
Yeah.
Ow!
It would.
No, it's crooked.
Okay.
I didn't say anything. Oh, can I do that one?
Okay, how about this hexagon? You're going to have to come up here and draw as many as you know how to do. So, Sabrina.
Okay. That won't work. Flip. That doesn't work.
Keep going, Sabrina.
Well, that's all I was going to put.
Okay. All right. That's all you got. Okay, do all three of those work? Thumbs up or thumbs down?
There's more.
And there's more too. Wait.
Okay. Do they all work or not? Right. So far these all work. Raise your hand if you have any more that you want to add on. Okay, Colton. Between him and Sarah just came up a minute ago.
Kind of looks like a spider web.
Thank you. Are there any more?
This can go on for a while.
You can just keep doing.
Any others?
Wait,
I don't think so. I think that's it.
I want to do that one.
How about the parallelogram? Just two people that want to come up? No one doesn't work.
I'm just asking.
Oh, let me take this.
Doesn't work.
What did you say, Marcus?
No.
You don't think it works?
It
What
only
if I
works one way.
go diagonal like that?
Yeah.
No.
Yes.
Yeah.
Where would it place this point here?
Yeah,
It would move it up, wouldn't it? That wouldn't quite work. It's close, but this point would get reflected onto this one.
Slanted diamond?
Apparently it's not.
Oh, well, it looks like it.
It's not a rhombus. It's a parallelogram. Right? Because these two lines are parallel. Those are parallel, so this is a parallelogram. So are these. Okay? So you can use a variety of different figures. Sometimes there are a lot of lines of symmetry. Sometimes there are none. This kind of a hexagon is called a regular hexagon. All the angles here are congruent, and you have lots of lines of symmetry. How many do we come up with? 1, 2, 3, 4, 5, 6, 7, 8? Or 6?
12. There's 12. I counted.
6. 6 lines.
Initially, so there's 3 more.
Okay. So that is reflectional symmetry. There's also a kind of symmetry that's called rotational symmetry. So turn over to page 84 if you haven't already in your booklet. On page 84, you'll see that a rotational symmetry, Dylan, Brendan, page? A rotational symmetry is any symmetry that you can rotate between 0 and 360 degrees. So if you go all the way around 360 degrees, that'll just obviously end you where you started, right?
Yes.
Okay. But is there a way to turn some of the figures that we were just looking at? Is there a way to rotate some of these shapes between 0 and 360 degrees so that they're identical to the pre-image? So, can I take this rectangle and rotate it between 0 and 360 degrees somehow so I end up with the same shape as I did in the beginning, so that the image and the pre-image match? Sadie.
Do it 180, but it's
So Sadie's thinking you could rotate this 180
If you took
degrees.
like the corner of it and rotate it like that, then it would be over here and then
So if I took this corner here,
uh-huh.
where would it end up when I rotate 180 degrees?
Oh, never mind.
It would be in the same
Over here, right? Would that work? Would it be the same shape?
Oh,
Yep.
Would it look exactly identical? Yes. Now you'd have to pick where your point of rotation would go, but you're allowed to do that. You could rotate it from any point. As long as you rotate 180 degrees, it will end up looking exactly like the pre-image. Is there another rotation you could do between 0 and 360 to get the same one?
Bottom right and top.
Sure, but is there another angle that you could rotate it through between 0 and 360?
This is confusing me.
360, but it's between 0 and 360, so that doesn't include those values. So, any figure you can rotate 360 and end up where you started with, right, Aaron? Like this triangle here on the left, if I rotate it 360, I just end up back at where I started. But there is no rotation between 0 and 360 that will give this triangle the same pre-image as image.
So technically, yeah, never mind. I'm just confusing.
How about this hexagon? Can I rotate this one at all between 0 and 360 degrees so I end up where I started? Okay, so raise your hand if you have an angle of rotation that would work. Cool. 180 would work. Yeah? Thumbs up?
No.
90? Will 90 degrees work if I rotate this thing 90 degrees? Yeah, it would.
Wait, what?
No, because then it'll be like.
Oh, I see what you mean. Because this point would end up over here. Is that what you're saying? Yes, 90 degrees would not work.
But
Good call.
98,
45.
whatever that
No.
was. However that is.
Between here and here?
No, keep going. Keep going.
Between here and here?
Yeah. However
Between these 2 points?
that many is, then yeah.
Well, how do you figure out how many degrees is each one of these little guys here? Well, there's 360 all around, so.
There's 30 each. 369. You said that was 90, and there's 3 in the 90, so it's worth 30 degrees.
So we're trying to figure out what this angle is
That's
in
60.
here. 60. Okay. So I can rotate 60 degrees and that would work, right?
Yeah.
Can I rotate it? How much is it over here?
100.
120. How much is it over here?
180.
Okay. And then over here. Right here. Thank you. And 300. So there are a lot of them actually in here. 1, 2, 3, 4, 5, 6 different kinds of rotations you could do between 0 and 360 degrees.
A lot.
How about the parallelogram? What rotational symmetry is there in that one?
I don't care.
180? Will this one end up over here? Would those work? Yeah.
But then the other side would be the same.
They would. If you take this point and rotate it around over here,
Oh, and the other point.
you couldn't do 90, but you
Would
could do
they
it.
be?
Yeah, it would work.
You'd have to actually rotate it for you to be able to see it.
Okay.
Because it's really confusing.
Wish I could
just
do that.
imagine like
Okay.
this.
Let me try to make you happy here.
Thank you. Appreciate the comment.
Okay, parallelogram? Ish, right? Okay, so if I say transform, rotate, how much are we rotating? This is interesting. 180 degrees. Say insert. See how it's the same shape?
Yes. I think you could like almost rotate on anything as like a triangle.
I think you can rotate anything 360 degrees and it will be the same.
Well,
But
yeah,
180
in
it's back
between
in the
it's
same
different.
spot.
Sabrina?
I'm trying to clear things up. So is there a line of symmetry in a parallelogram?
There's no reflectional line of symmetry in a parallelogram. But we're talking now about rotational symmetry.
Yeah, I know.
And there
I'm
is
just
one.
trying to go back to those.
Yep.
Is there?
So the answer to that question was no, there is no reflectional line.
But whether you have one or not, you just need it.
Yeah. Okay. In any regular polygon, how do you determine the angle of rotation? We just did that. Okay, the last kind of symmetry is called identity symmetry. Oh, you know what? Your job is to go back to this triangle ABC here and find the center of rotation. So if you look in your text, this spot right here in your text, bummer, wrong one. This spot right here in your text tells you what to do in order to find the angle of the center of rotation. So follow those steps with your partner, see if you can do that. Right next to the triangle, there's some information on how to do that. It's also up on the screen if you need it.